Welcome to One Chemistry. Always try to do your best. Now, let us see about 100 concepts in organic chemistry. We are seeing it as episode. This is the episode number 60. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the first question. The first question is about Diels-Alder reaction. They given the dienophile and diene with heteroatom. The heteroatom can be carbon, oxygen, sulfur and nitrogen. They are asking the product rate in terms of activation barrier. So you have to find what happened when the X is changes to heteroatom. Does the heteroatom promote the reaction or depromote the reaction? So you have to find which is higher, which is lower in the activation barriers. From the question of different dienophile and 4 different choices, you might realize the question is really about Diels-Alder reaction versus heteroatom. The answer is C. Let us see how. Here the reactivity or the activeness defined by the electron richness. If the ring is electron rich, reactivity will be higher. If ring is electron less, reactivity will be less. Before the analysis, you have to know the electronegativity. Sulfur is electronegative than nitrogen, then oxygen. So oxygen is very high electronegative. What really happens is high electronegative atom don't allow the electron to participate. The electron don't participate in the ring, so resonance will not be effective. So the resonance energy is high. So if you compare all 4, the 4th one is not aromatic because of no conjugation. Definitely it will have very high energy or it won't have any significance. So it will be the least one. If you analyze the highest one, sulfur will be the highest one because of less electronegative, very low resonance energy, electron is rich, reactivity is higher. Then if you compare nitrogen and oxygen, oxygen will be the least one because of the electronegativity. So if you look at the trend, sulfur will come first, then nitrogen, then oxygen, then carbon. So the answer is clearly C there. Here the concepts we have to learn here is high electronegative atom don't allow the electron to participate in the ring. So the ring is less electron rich. It defines the reactivity of the reactant. So more reactive alkene means less resonance energy, less activation energy and electron richness. Then let us look at the next question. They given the 4 different bromides there. First one is bromine attached with bicyclic system which contain one alkene. Second one is cyclopentene and it has one methyl with bromide. Third one is cyclopropene again with methyl and bromide. Fourth one is cyclopentadienyl and it will be with bromine and methyl. They are asking rate of solvolysis. You may think of any solvent and find the rate of it. They ask you to compare the order. So if you look at the 4 different reactants and the question of solvolysis, you might realize the question is really about intermediate versus rate of reaction. The answer is C. Let us see how. Here bromine leaves mean they form the cation, so you have to find the cation stability there. Let us analyze the extremes first. The third one is aromatic because cation formed in the cyclopropene ring. It is with one alkene which is 2 pi electrons, so it is aromatic, very stable, the cation form easily and it solvate easily. So third will be very reactive. But if you look at the 4th one, the cation is formed in the cyclopentadienyl ion, so it will be anti-aromatic. Because of 4 pi electron, it will be 4n system, it is anti-aromatic. It is very much unstable, it won't form at all. So very low solvolysis. So the real competition between 1 and 2. 1 and 2 it will be easy to compare. 1 if you remove the bromine, you form the cation at the bridged carbon, so cation don't form easily. So 1 will be least reactive than 2. 2 has the advantage of allyl cation, so it will be very stable than 1. So if you compare the order, third will come first, it is aromatic, second will come next, it is the conjugated system, then the first, the bridged cation, fourth will be the anti-aromatic one. So the answer is clearly C there. So the concepts you have to learn here is the cation don't form at the bridged carbon, then the intermediate don't form if it is in the anti-aromatic state. Then let us look at the next question. They given a structure with 7-member and 5-member fused system, which is a kind of acetylene. You have to find why the compound has high dipole moment. The system is conjugated. You have to analyze the possibility around it. They given the reason for aromaticity because it only obey Huckel rule, or due to conformational stability, or due to different ring size, or charge separation due to aromaticity. So from the question of dipole moment, possible 4 answers, you might realize the question is really about stability versus dipole. The answer is D. Let us see how. Here the charge separation due to aromaticity. Let us analyze why it is. Here the structure A and B are there. You can create aromaticity in both rings there. By moving up the electron, you can have A ring cation, B ring anion. This anion and cation is very stable due to aromaticity. Because A ring has 6 pi electron and cation provide conjugation, it's very stable. So the system is aromatic. There it's a very stable cation. If you look at the B ring, it is also aromatic because it takes up the electron from the A ring and it take another pi electron and anion, it will become 6 pi electron. Both charges are very stable due to aromaticity. The dipole start from positive to negative. This is the direction of dipole there. So the answer is clearly D, charge separation due to aromaticity. Here the concepts you have to learn here is, if the system create the aromatic cation or anion, it will be very stable and permanent. It will create dipole moment. Then let us look at the next question. They given the compound with alkyne and ether. They have different protons. They ask you to find order of chemical shift. Whether you have to find alkynyl proton have higher chemical shift, or methylene has higher chemical shift, or the methoxide proton has higher chemical shift. Basically you are differentiating the protons there by chemical shift. So you have to find the order among them, which is higher, which is lower. So from the structure with different proton and the order of chemical shift, you might realize the question is really about proton shielding and deshielding versus functional groups. The answer is D. Let us see how. Here you have to find the deshielding by different electronegative atoms. Here two electronegative groups are there. One is oxygen, another is sp hybridized carbon. sp hybridized carbon is more electronegative due to more S character. So it will be more acidic there. So you have to compare accordingly. Here if you look at it, Y will be very high because it is attached with two electronegative system. One is sp hybridized carbon and oxygen. Two electronegative system, more deshielding, higher will be the chemical shift. Then if you look at between X and Z, X will be more acidic than Z. Why? Because it attached with electronegative atom, which is higher than the hybridization. Because hybridization is come from S character, oxygen is natively electronegative. So X will be higher than Z. So if you look at the order, Y will come first, then X, least will be the Z1. Here the concepts you have to learn here is electronegative atom increase the chemical shift by deshielding. Second thing is sp hybridized carbon should be treated as electronegative because of more S character. Then let us look at the next question. Question is about boiling point. They given the 4 different oxygen functional group, alcohol and ether. You have to find the difference among the boiling point. First one is linear alcohol, second one is ether, third one is branched alcohol, fourth one is completely branched alcohol. You have to find the correct order of boiling point. So from the 4 different alcohols and ethers and the question of boiling point, you have to find which one is higher and which one is lower. So the question is really about different isomers versus its boiling point. The answer is C. Let us see how. Here before we get into solving problem, you have to find the concepts here. The boiling point increases with number of carbon. The boiling point also increases with hydrogen bonding. Second one is linear form better hydrogen bond than branch. So higher the boiling point will be. So linear have higher boiling point than branched. So let us analyze the extremes there. The second one, if you look at it, is ether, no hydrogen bond. It is expected to be very low. If you look at the first one, it is 4 carbon, linear, very high boiling point. You have to compare between 3 and 4. 3 is carbon is very branched, then the fourth carbon, because alkali groups away from the system. So 3 is higher than the fourth one. So if you look at the order, 1 will be very high, then 3 will come, later 4, least will be the second one. So the answer is clearly C there. So the concepts we have to learn here is the boiling point increases with the number of carbon atom. It is also increases with hydrogen bonding. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.